I'm going to be talking about stoichiometry and basically how to do it. So for starters, you need to know units because stoichiometry is basically the conversion of units. So up here, I have a list of units that go in order based on scientific notation. So a good mnemonic device to remember the order is Mighty King Henry died by drinking chocolate milk Monday night. So Mighty King Henry died by drinking chocolate milk Monday night. That's the easiest way for me to remember it. So basically an easy way to go through this is you have your base, which is 0, and if you want to convert your base, which is in meters, your base is in meters. If you want to convert that to, let's say, centimeters, it's whatever your number is times 10 to the negative 2. Because you have your base here and you want to go to centi, so move over 2 spaces that way. That's 2 spaces in the negative direction. If you wanted to make it kilometers, you would move 1, 2, 3 in that direction, and it would be your number times 10 cubed in order to get it in kilometers. So that's the easiest way to use that chart, and this is a funny little number called mu. I honestly don't know how that's a unit, but there you go. And right here, in between the M and the K, and the another M and the Greek letter mu, that's where there's a jump in units. So here you go by 1, so you have 10 to the first, 10 to the second, 10 cubed. And right here, you would jump to 10 to the 6th. It goes up by 3 places. So it would jump from 10 cubed to 10 to the 6th. Same thing goes for down here. This is 10 to the negative 3, and as soon as you jump across that line, it's 10 to the negative 6 and continues like that. So from here to here, it's 10 to the negative 9. So you have 10 to the negative 3, 10 to the negative 6, 10 to the negative 9. Fun stuff. So if you want to convert something from meters to nanometers, you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and it would be your number times 10 to the negative 9 to be in nanometers. Now, let's just put a little bit of this to use in a simple problem. So here we've got convert 51.4 centimeters to inches. Now, and the easiest way to do stoichiometry is to line up your units. So you have 51.4 centimeters. To convert it to inches, you want to be multiplying by something where there's centimeters on the bottom in order to cancel out your units. So you're going to have centimeters on the bottom and inches on the top. So for every 1 inch, there's 2.54 centimeters. So when you multiply that out, you got 51.4 divided by 2.54, and this cancel out. So all you're left with is your unit in inches. So your answer is going to be about 20.2 inches. Now remember, canceling out your units is the easiest way to do stoichiometry. If you just line them up oppositely, that's how you know you're going to be going in the right order. So this type of stuff is really, really helpful when calculating yields or limiting agents in chemistry and that type of thing in chemical reactions. So here we have an example, and we have the chemical equation 4NH3 plus 5O2 yields 6H2O plus 4NO. Now the question is, how many grams, pay attention to units, how many grams of O2 are required to produce 0.3 moles, moles is different, 0.3 moles of H2O. So you already know that you're going to be solving for O2 because it's asking how many grams of O2 are required. So you're going to start with 0.3 moles of H2O. So you have 0.3 moles H2O. And remember, you have that unit on the top, so that means you want to cancel it out on the bottom. Now, this is where you're going to be using coefficients. So you have a 5 right here for O2 and a 6 right here for H2O. So if you have 0.3 moles of H2O on the top and you're trying to get 2 moles of O2, you would do 6 moles of H2O for every 5 moles of O2. Now, that would cancel out moles H2O and moles of H2O. So you're left with 0.3 times 5 moles of O2. Now you want to get rid of, or you want to switch moles of O2 into grams because that's what it's asking for. So you're going to put moles of O2 on the bottom and grams of O2 on the top. Now this is where you would grab your handy dandy periodic table and figure out how many grams are in 1 mole of O2. And that's 32 grams for every 1 mole. Now if you multiply all that out, you're going to get 0.3 times 5 times 32 grams. I don't have a calculator, so I'm not going to be able to do it, but that's the gist. So you've got moles of H2O crossed out there because they're opposite from each other, moles of O2 crossed out here because they're opposite each other, and all you're left with is grams of O2, which is what we were solving for in the first place. So the easiest way to tackle stoichiometry is to not only have this fun chart memorized, but also to realize that you have to line up your units in order to end with the correct unit. So if you want to convert centimeters to inches, make sure your centimeters are across from each other. That way you can end up with inches. If you want to go from moles to grams, make sure you use the mole ratio and you have your units across from each other so you can end with whatever's on top. That's the easiest way to tackle stoichiometry, and yeah, thank you for watching.